18th, day 3. Systems of equations. Solving systems of equations through either substitution or elimination. A system of equation means there's more than one. There can be 2 or 3 equations with 2 or 3 variables or more. We reviewed specific ways to solve these. The first example I'm going to work is solving a system using substitution. Now, the first equation is x equals 4y minus 10. Second one is 5x plus 3y equals negative 4. These are 2 lines. Blake. These are 2 lines. If we are trying to solve, that means we're trying to figure out what? We're trying to find the point where they cross each other, which means we're gonna be finding x and y. We're going to be finding an ordered pair, which is a point on a graph. Now, when's the only time 2 lines don't cross each other?
Parallel.
When they're parallel to each other. How can you tell if 2 lines are parallel to each other? By looking at the equations, if they have the same slope. Very good. Okay. Now here, these 2 equations were ready to go for substitution, because to use substitution, you have to have either x equals or y equals. And since we are already here with x equals this expression, then we can substitute this expression into the second equation for x, which I have 5 times x, which x is equal to 4y minus 10, plus 3y equals negative 4. Now if you notice, what I've accomplished by substituting is I no longer have 2 different variables. I just have y's. And so we can solve the equation for y. We start by distributing the 5. Notice we don't distribute to plus 3y because it's not in parentheses. We add like terms. 20y plus 3y is 23y. I'm going to add 50 to both sides in order to bring it to the other side. It gives me 46. And then I divide both sides by 23. So y has a value of 2. Now if you recall, notice I have the arrow drawn at the top. It's because we need to finish or complete our cycle. If y is equal to 2, then we're going to plug that into our other equation to find our value for x. So x is equal to 8 minus 10, or x is equal to negative 2. Now remember, I said we just found an actual point on a graph. How do you label a point on a graph? What's it called? A what pair? An ordered pair. This is an actual point where x is equal to negative 2 and y is equal to positive 2. So your answer needs to be written as an ordered pair. Systems of equations through substitution. We also had solving systems using elimination. Now here I have 2 equations with 2 unknowns, and for elimination I need everything to be lined up perfectly. Notice your or terms, your plus and minus sign, your s terms, your equal signs are in the same exact spot, and your constants are together. And that's because we're going to actually add like terms in column form. But our purpose and our goal is to get rid of either or s. Well, if I simply add it up like it is right now, I'm not going to get rid of either one. I'm still going to have an or and an s. So what we're going to do is transform either one or both equations so that we can get rid of them. Well, the easiest thing to do here is to turn this or into what? Negative 2, because negative 2 plus 2 is 0. Well, to do that, I have to multiply everything up there by negative 2. All right? And I'm going to rewrite that equation underneath. It gives me negative 2r minus 10s equals positive 34.
Why'd you pick -2?
How'd I pick -2? Because I want these coefficients to be the same number.
If that was 3, you picked -3.
Exactly. All right. Or if it wasn't something that you could just multiply 1 by, let's say we were trying to get rid of the s's, I would think of a factor or a multiple of 5 and 6, which would be 30. So I'd want to turn this into 30 and turn this into 30. So you'd multiply by whatever it took to do that. Okay? Now here, 2r minus 2r is 0r. There's no more r. We've accomplished our goal. This is negative 16s, and this is positive 32, because negative 2 plus 34 is 32. And then we have one equation here, one variable. We're going to divide both sides by negative 16 to find that s was equal to negative 2. Are we done? No. Because remember, these are two lines, and I'm looking for the point where they cross each other, so it's got to be an ordered pair. So what I do is take this solution, and I plug it back into one of the original equations. Either one, it doesn't matter. I'm going to use this one, simply because I want to. Okay? So r plus 5 times s, which is negative 2, is equal to negative 17. So I have r minus 10 equals negative 17, and I add 10 to both sides to get r equals negative 7. Again, this is an ordered pair. I just found r and s. Hey, it's not x and y. What order do I put it in? Alphabetical order. R comes before S in the alphabet, so your R coordinate comes before your S coordinate in your answer. You simply go in alphabetical order. Systems of equations. All right, and then you are going to have to graph lines, but we are going to have to, we've already done this, so let's do it again. X equals 2. How do you know if something's a straight line? It's either got x by itself to the first power, it's got y by itself to the first power, or it's got x and y, but they're both to the first power. All right? Any equation that looks anything like one of these three is the equation of a line. Again, x equals 2 is what kind of line? It's a vertical line. Y equals 5 is what kind of line? Horizontal line. All right? And this third one has a slope to it, specifically because the coordinate of x is positive, it has a positive slope. And we touched on this briefly last week, but is that a direct or indirect relationship between the two variables? Direct. It's a direct relationship. A positive slope means as x gets bigger, so does y. Okay? Both of them are increasing together. That's direct. We had equations of parabolas. What's the key element that lets you know that it's a parabola? One of the variables is squared. Only one of them. You've got x and y, but only one of them is squared. Okay? You are not going to have to graph a parabola. You're simply going to have to identify what it is. Like if I gave you this, you're going to have to tell me that's a parabola.
We have ellipses and everything else.
Yes. Okay?
So we're not going to have to work it at all?
Nope. You're just going to identify it. All right, now remember, for memory purposes, if x is squared, is the parabola opening left and right or up and down? Up or down?